Assalamualaikum and a very good evening. I bid to my lecturer, Dr. Asmawi, and to my fellow home group mates. My name is Danish Dofika. I am from Expert Group 6. So today I'll be sharing about the Vane shear test and also the borehole test. So what is Vane shear test? Vane shear test, it is a method of evaluating the undrained shear strength of cohesive soils, particularly clays. It serves the purposes of determining cohesiveness soils in a laboratory setting. For borehole shear test, it is a method of evaluating the shear strength properties of rock masses. Its purposes is to design for in situ assessment of shear strength in rock masses. So, next I'll be sharing about the theory and the formulas of both of the tests. So the theory for the Vane shear test, it is used to calculate the undrained shear strength of fully saturated clays in an undisturbed environment. The test is rapid, easy to conduct, and offers a cost-effective method of determining the soil shear strength. If silt or sand is included in the clay, the test findings are not that accurate. It is frequently used in situ testing, while it can also be performed under certain circumstances on undisturbed soil specimens in a lab. The formula is given as below. So for the borehole shear test, it is a unique alternative in shear strength testing of soil and rock. In contrast or difference to Vane shear test, this test gives discrete values of friction, angle, and cohesion. Therefore, more complete analysis may be made for such fundamental problems as bearing capacity and slope stability. The formula is given as below. For the next slide, I'll be sharing an example or calculation and also figure for the Vane shear test. So for the question below, a Vane shear test was conducted to determine the undrained cohesion of soft clay. The vane was 11.25 cm high and 7.5 cm across the blades. The equivalent torque recorded at the torque head at failure was 312.5 kilograms centimeter. What will be the undrained cohesion of the soft clay? So from the question, we can know that the vane height, which is labeled as H, is 11.25 cm. The vane width, labeled as D, is 7.5 cm, and the applied torque, which we label as T, is equals to 312.5 kilogram centimeter. So from that, we can insert the value into the formula below. So S is equal to 312.5 over pi in bracket 7.5 square times with 11.25 over 2 plus 7.5 cube over 6. And the answer is 0.257 kilogram per centimeter square. For the next one, I'll be sharing about the calculation and figure for the borehole shear test. So, a series of borehole shear tests was conducted within the project site utilizing two shear heads with the dimensions of 50 mm times 50 mm. Inner gas was used to press the two plates to exert normal stress to the borehole wall. Assuming uniform size of piping system, determine the soil strength parameters obtained from the in situ test, and the information gathered from the test are tabulated as below. So for the solution, we can take for the test number 1, we can use test number 1 as an example. So the applied normal stress is equal to applied force over shear head area, and it can also be derived as applied pressure times shear head area over shear head area. And from that, we can insert the values from test number 1, which is 30 kPa times with the dimension which is 50 millimeter times 50 millimeter, and change it to meter, and the answer is 30 kPa. As two shear head plates were utilized, the values of shear stress developed between the shear plates and borehole were calculated as T is equal to pull-out force over 2 times shear head area. So we just insert the value, which is our pull-out force is 152 over 1000 kilonewton over 2 times the dimension, and the answer will be given. And for the next one, the calculated values of normal and shear stresses are as shown in table Q1. The obtained shear stresses are then plotted against normal stresses as illustrated in figure Q17, which yields approximately a straight line. So we plot the graph, and from the plotted graph it can be deduced that the soil strength parameters are cohesion, which is C equals to 16 kPa. 16 kPa is the interception point between the best fit straight line and vertical axis, and the internal shear resistance or internal friction angle is counted as below. So as a conclusion, the Vane shear test, it involves rotating a blade inserted into a soil, and shear occurs along cylinder surface, shallow depth, limit to insertion depth. It might disturb to the soil structure for cohesive and soft soils, and for quick assessments and preliminary investigation. For the borehole test, we can conclude that it involves pushing a specialized tool into a borehole, and shear occurs along the borehole wall where the tool is pushed into the soil. It has various depth, allow depth-specific shear strength analysis, and shear strength that represent the different depths of within the borehole will be provided. The wider the soil types range, both cohesive and non-cohesive soil. I think that's all from me. Thank you very much.